Hi, I'm Tom Stephenson, Professor of Construction Management. In this series, we're looking at how to read and understand construction drawings. Print reading, blueprint reading, whatever you want to call it. Today, we're going to be looking at commercial site plans. This is lesson 3. In the previous 2 videos, we looked at different sets of residential site plans. So I thought it'd be interesting to take a little look at a simple commercial site plan and expand upon some of the things that we've talked about in the previous videos. If you're interested in learning more about understanding construction drawings, you can look at my playlist, subscribe to my channel, click on the notifications icon, and you'll see new videos as they come up. I've also written a textbook called Understanding Construction Drawings for Housing and Small Buildings, and it's actually in its 4th edition. It's available on Amazon. Okay, let's get started. So we're going to be talking about a commercial site plan today, but why do we have site plans to begin with? Well, one of the things I'm going to stress in this series of videos is, number one, you want to visualize things, and a site plan will help you visualize exactly where the building is going to be on the lot, some of the existing conditions potentially, some of the various elevations and slopes on the property. Sometimes it'll show existing grade and finished grade. Sometimes it'll just show finished grade depending on the type of drawing. It is a requirement to get a building permit. You know, they want to make sure, the town or municipality or city wants to make sure that you're building it in the right place. You've sized it according to their zoning requirements. Most towns, cities, and areas will have zoning requirements regarding how far the building has to be set back, its proximity to adjoining lots, building code requirements for things like what we call in Canada limiting distance. If there's a fire, you know, it may hop from one building to another. So where are the openings? How big can the openings be? Can there be any openings depending on how close the building is to the property line? So there's a lot of requirements that come into play there. And more that we'll discuss in these series. So as I said, site plan gives you a lot of information, but let's just take a quick look at some of the things that we should think about, and some of the things I haven't covered that much in the other videos, although I did talk about levels and elevations. Benchmark is a reference point. So usually a benchmark is referencing mean sea level or average sea level. And everything is sort of laid out and been measured, surveyed over the years and decades, and there's markings in every town and city at what the elevation points are, and they're reference points that then whoever is laying out the building can reference from that, and so that the elevations will tell you how deep you can go, so that the footing will be at the right depth, so when you build the actual building, the first floor will be at the right amount above the finished grade. And the finished grade, what elevation do we want that? So everything is referenced from a benchmark, which is important from that perspective. You know, if you're just doing a simple building, it may not be referenced to mean sea level. They might just use a number like 10 or 100. And that just ensures that you know what depth you're going to go in relation to that benchmark. Very often a local fire hydrant might be used, and that might be benchmarked at that particular elevation, and that way you're not dealing with negative numbers for those purposes. So if you see all of a sudden a benchmark is listed at 100, that's what's going on, because there's no way the mean sea level is going to be exactly at 100 where you're building it. Very, very unlikely anyways. Okay, so good example here. This is a close-up zoomed in. It says top equals BM. Almost looks like an 8, but BM, benchmark, elevation 100. All right, so that's just saying the top of the fire hydrant. That would be a symbol for a fire hydrant in that case, and it tells you it right there. And this is in metric. So those of you that may be using imperial measurement wherever you're from, the difference is it's all the same the way it's referenced. You know, that could be at 100 yards, or that could be at 100 feet, depending on what it is that you're referencing. For us in Canada, it's typically going to be in meters, and so that's what that's referring to. All right. So We also should say that site plans, plot plans is another word for a site plan. United States, they usually call it plot plan. We tend to call it site plan. I think out west we tend to call it plot plan as well. They mean the same thing, and it'll show things like typically fences, existing structural retaining walls, maybe swimming pools, storm drainage, paved and unpaved areas, catch basins. There's usually a legend. Always look at the legend. Whatever drawing you're using, look at the legend. Especially I find site plan, they tend to have a number of different symbols that they use from drawing to drawing. And the name and address of surveyor who supplied the survey for this site improvement plan, or site plan if you will, is very often shown as well. Maybe a registered surveyor, like in Ontario, Canada, we say OLS, Ontario Land Surveyor, as an example. It'll also typically show existing trees and shrubs, maybe above a certain size. Site plans can also be converted to landscape drawings, specific civil drawings, variety of different layout drawings. Landscape drawings would be very detailed. Maybe there's tree protection zones that have to be put up. Certain trees need to be protected over a certain size. Maybe it would indicate trees that could be removed because they're dying or they've got some sort of disease or something like that. Detailed. Then there's other landscaping drawings that'll show where the plantings are going and where the new trees are going, and list them and have tables that associate with it. So these are related drawings, but the site plan typically is going to be very detailed as far as showing you where the building is going to go in relation to the property, and providing that information. And if it's on a simple drawing, it may be having everything on the one plan. Okay, so we take a look at it from that point of view, and there would be contour lines. Contour lines are lines that show the elevations at various points, and we'll take a look at that very shortly. Contour lines, if they kind of go around in a circle, then it's either going to be a hill or it's going to be a depression or a ponding area, because it'll be enclosed with a circular contour line, and that would typically perhaps fill with water. Or it might be a designed pond, like a storm management pond, that's put in there for a reason. You'll also see certain indicators like valleys in the contour line that are following each other. That usually will indicate that you've got a little bit of a swale that's in that spot, and it will usually point upstream where the point is. And I think I've got an example of that in an upcoming little snippet here. So here's your contour lines. And contour lines, you may find that they may show existing, and then they might show the finished grade. In this case, it's showing the, in this particular case, well, I don't actually have the legend, so I'm not 100% sure, but because they switch them around, like I said. So this is probably going to be the finished grade, perhaps, just looking at it. The high point is where the house is, and then it's going lower towards the outside edges, 104, 103, 102, 103, 102, 101, 100. So it's basically sloping both directions away from the house. Usually you'd also want right around the house to be at the highest level, perhaps maybe about 150 millimeters or 6 inches higher than the surrounding area, so it slopes away from the house. All right, and so as I said, contour lines will give you those indicators. Now, if they're fairly close together, it indicates it's a steep slope. In the previous videos, we looked where there was a steep gradient change and there was a different hatching for that. In this example today, we'll look at where the contour lines are pretty close, and that just means it's steep in that particular area, and that when they connect around, they basically form that sort of hill or pond that I was mentioning. But you got to remember that every point along this line, it's telling you that it's at that elevation. So if it squiggles off a little bit, that means that it changes an elevation at a certain point. And I think this one is actually the existing grade, because it's kind of off in a few spots. More likely when this would have been finished graded, it would be probably more even of a slope. All right, and so here's a good example here. We can see in this area here, there's a storm pond. And so the base of the storm pond is pretty much leveled out because that's going to be where the water is going to be filling up. So the base of it, they don't want it to be having high and low points where some is out of the water and some is not. So they pretty much have that leveled out. And you see that along here, these lines are pretty close together. And so 128, 127.5, you can see it's going down. So the number is going down. Same thing over here. Number is crested at 127.5, 128 over here, following that contour line, and then it's flowing downward in that direction here. You can also see existing trees. These circles here are representative of existing trees that are circling around the pond. And we can also see some shrubs around here that's pointed out. We can see these little points here. So this would indicate here that there would be kind of like a swale almost flowing down towards the water in this direction. So swale, and then it's kind of a more uniform kind of falling down of the water in that direction. So we see a bunch of those different indicators flowing around, and oh, these little symbols here are for boreholes. Again, if you had the legend, it would tell you that's for boreholes, and the boreholes are numbered. Essentially, the boreholes are done for geotechnical surveys and studies to reference a whole bunch of different tests that might be done on the soils in that particular area to check basically the soil types, perhaps, to see if there's any toxins in the soil, if it's a brownfield site that basically maybe it was a former factory area or those types of things. So the boreholes can be done for a number of reasons and are required typically. So contours, as I said, are placed closely together. That means it's more steep, and if they're farther, it's less. So you can see in this particular example, this is our commercial building here, and it's always helpful to try to figure out what you're actually looking at and try and reference that. So let's see if I can get a highlighter maybe going here. Maybe go with yellow. That looks like I've got it here. And so we will go draw some lines across here, see if you can see them all right. So that's yellow. That line there is a property line. And then I'm going to go down. I think I went a little bit too far with that property line. It's going to be a little bit squiggly here, but we'll just follow this down. Continuing to follow this down here. And I'm going to bring it across at the property line. Nice wide line here. Bring it straight up. I can connect that there. There we go. We can clearly see now that the outline here is following right along here, right along down there, right along here on the yellow, and up the side here. Okay, so that's the property line. Now we got to decipher where is the actual building. So maybe we use blue for that. So you got to look fairly closely. And in this case, I can see that the proposed new building is going across here. It's going down this side there. It's coming across here. And it's going up there. So now we can see where the building is actually located, right? So that is the perimeter of the building, which is important to figure out. Use the laser pointer. All right, so you see it says north here. Always look for that. Sometimes it's just outside the image. Here it's inside the image right there, but north, as we've said in other videos, that means that's west, that's east, that's south. All they'll ever give you is north that I've usually seen. And here, so going from the east property line towards the west, this is a setback, 7.6 meters. Yours, it could be, 20 20 feet, it could be 15 feet, 30 feet, dash decimal so many feet. This is the width of the building from outside to outside, 16.8 meters. From the west side, 8.4 meters, right? So you've got your width, you've got your location, you've got your setbacks. Here's your rear setback. Line is at flowing through, well, that looks like it's exactly in alignment with the building here. I would check that because easy to check. Here you've got 5,000, right? And then you've got, so 5,000 from the front property line. The building is 20.8 meters. 20.8 meters means it's 20,800 millimeters, right? So that's very easy, again, to check. You just move, in metric, you just move the decimal place 3 places. One for decimeters, centimeters, millimeters, right? So one, that's the nice thing about metric. Each space has a hole there. So all you got to know, if I'm dealing with meters, I move it 3 places, and then I'm into millimeters. Most construction drawings, you know, they'll measure out, if they're in metric, they'll measure out in millimeters. The actual architectural drawings, which we look at later, is going to show it in millimeters. So you got to know how to quickly convert one way or the other. Plus, if you're ordering concrete or something like that, very easy if it's given in millimeters to convert it to meters. That's the nice thing. You just go the other way, 3 decimal places. All right, so we can see where the building is set back from. We've got these different locators here. And yes, because this is 20.8, as I said, that tells you this is the setback from the north property line to the building, 12.6 millimeters. So now you know that those locations. So we can locate where the building, and this is the exterior building walls, are going to be located. So basically the outer part of the foundation wall. You can also see here, that's interesting, you see the dash line of existing foundations to be removed. So there must be an existing building here, or at least an existing foundation. And if you investigate the site, you should always go to the site anytime you're going to be quoting anything, looking at anything. There's this old saying that the map is not the territory, right? So this is the map, may not be exactly the way the map shows on site. So you always want to verify things and review it and check it on site. That's why usually also in the title block, it'll be telling you to verify dimensions and check with the consultants if there's any discrepancies, because there's discrepancies. The map is never exactly like the territory, but it's usually pretty good. All right. So we have that. We're showing that we would remove the existing. So these dashed lines, they mean a lot of things in construction drawings. They can mean hidden lines, and that usually means something that's behind something. We'll get into that more as we go further in the course. It could mean vents for plumbing pipes, it usually is a dashed line. It could be describing something that is an option, that if you want to pay extra for it, you can get it. It could mean that there is something like this that's to be removed. And for sure, see the contour lines? It can mean contour lines representing certain elevations. And in this case, it's the natural grade. So this is before it's graded. Finished grade on this particular set of drawings is given at a variety of different actually, the finished grade is given like at the where the finished first floor is going to be and where the structural slab is going to be on this simple drawing. Like on our previous drawings, it would show the underside of the footings. That would give you the depth that you have to excavate to. So there's usually a lot of finished elevations that are provided. So here you see a finished grade indicated by the box. And so this is showing you where you've got some finished grade elevations that are provided, right? And concrete path, 99.4, 99.2. That would tell you that this concrete path is going to slope from the building towards the road or the sidewalk out on the other part, right? South Street here. So 99.4 to 99.2, it's going to slope in this distance, 5,000, 15 feet, if you will, a little bit over the 15 feet. It's going to slope 200 millimeters, which is 8 inches. So it's going to have a pretty good slope towards the front. Here we've got 600 by 600 concrete paving slabs. That would be laid out in this particular area here. And so that's what that's telling you there. And they're going to be at 99.3 elevation. And we have also here, this is showing A1. This is for an architectural grid. On the architectural drawings, you would see basically a grid layout, which is tied to the planning grid or structural grid to show where key structural elements are. And this is basically your reference point. So you know when you look at A1 on the floor plans, this is where this is on the actual site plan, where you typically don't need the grid because you're not doing those structural points, but at least you know and you can orient yourself. You're always trying to orient yourself with the drawings, right? And these steel SIBs, this is for steel iron bars. I talked about that in a previous video, 1 or 2, and I gave an example. Those are basically your monuments that are driven into the ground, those steel iron bars, and that's showing you the corners of the property. Surveyors do that to indicate where the corners are of the property. And you can see what the elevations are at those corners as well. So if I was to ask you what is the highest elevation on the corners, you could merely look around and you could see, okay, that's 99.950, that's 99.525, that's a little bit higher. You'd see down here that's 98.820 and 99.450. So you know that it's kind of sloping a little bit this way, right? And you see here it's 99.4, and so you got 99.4, 99.525, that it is indeed sloping a little bit that way, right? So it's giving you a little bit of that information. You can see this is basically representing a little bit of a walkway or sidewalk around the outside of the building. This is an asphalt service area here for the building, and we have again here some infrastructure things: the water main, hydro, and telephone pole. So it says TP and HP, telephone pole, hydro pole, right? So it's indicating where they are. 300 represents the size of the water main, so it would be a fairly large water main at 12-inch size. Of course, we see some simple legend points over here: benchmark, telephone pole, hydro line pole, steel iron bar, natural grade. You should get a good sense of elevations, contour lines by looking at this drawing, and how it's set back from the property lines. First step, figure out where the property lines are. Next step, figure out where the building is, right? And visualize that, and then you can get a good sense of what is actually going on in that particular case. We'll talk about scales in another video, but this is scale 1 to 200, so it's 1/200th full size. It's been greatly reduced, and that's what we do with drawings. We reduce them. That basically means that every millimeter represents 200 millimeters in real size, or every foot represents 200 feet in real size if it was represented that way. It's a ratio. Okay, that's what I wanted to get done today. This is Tom Stephenson wishing you a wonderful day, and don't forget to click the subscribe and notifications icon so you can see more videos as they come up on print reading. And you'll see many on my different playlists that are related to construction, project management, Microsoft project, trying to help everyone along in our construction community. Bye for now.